about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready, 'cause this stream is about to start. Hello everyone and welcome to day 18 of Advent of Code. We have been doing this for 18 days already. Wow, time is flying. And with me, I have David, who is now just a blob. I wonder if my internet is as good as it should be. I think it's not. I think my internet is not as good as it should be. But David, can you hear me?
I can hear you. I can hear it's kind of cutting out, so I'm not sure if that's an issue on your end, but it may well be.
It may be, because I can see here that the stream is not...
Yeah, we're back. Am I frozen?
It seems like you are frozen, but it seems like we are back, so how about I just do this, and now you're back. And now...
Okay.
It's not as smooth as it could be, but we should be good to go. So let's get started.
Let's do it.
Okay, day 18. David, it's all yours.
All right, big moment. Lava Duct Lagoon. Thanks to your efforts, the Machine Parts Factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They've asked you to take a look at the dig plan, your puzzle input, for example. Okay. The digger starts at 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left, right, clearing full 1 meter cubes as they go. The directions are given as seen from above, so if up were north, then right would be east. Right, yeah. And so on. Each trench is also listed with the color that the edge of the trench should be painted as an RGB hexadecimal color code. Oh, I'm sensing some visualizations.
Yeah.
Going to be in this thing. When viewed from above, the above example dig plan would result in the following loop of trench hash having been dug out from otherwise ground level dot. Not sure I follow that. At this point, the trench could also contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well.
Mm-hmm.
Now the lagoon can... Yeah, I'm not following the diagrams very much at the moment.
Well,
now the lagoon can contain...
So we start at the top left. Let me split this screen to make this more convenient.
I see.
So we start at the top left and we go to the right for for 6 squares. So I suppose this is going to be 1, 2, 3, 4, 5, 6. Ah, okay, no, actually we start here and then we go 1, 2, 3, 4, 5, 6. And then we go down for 5. So 1, 2, 3, 4, 5, and left and so on.
We start at 1, 1.
We start here, yeah.
Yeah.
Hello, Bo.
Yeah. And then it's like, okay, the next step is to fill into the interior.
Mm-hmm.
Okay. I can't really read the text fully now. Yeah.
I'll do this.
Dig up. That's cool. Well, we hadn't read the line above. Well, anyway, maybe we had. Now the lagoon can contain.
Yes.
Yeah,
We read that now it is find the interior of the area.
now the lagoon can contain much more respectable 62 cubic meters of lava while the interior is dug out. The edges are also printed according to the color codes in the dig plan. The elves are concerned the lagoon won't be large enough if they follow their dig plan. How many cubic meters of lava could it hold? Okay.
Wait a second. We have seen this before. This is day 10 all over again.
Yeah, flood fill the inside.
Is there anything
guess.
tricky? Maybe the outputs are outrageous? I don't know. I feel like this is day 10 all over again. And we know how to do day 10, so let's do it.
Well, that's interesting because there's also been I mean, I don't know if we want to second guess too much, but there's also the thing of like whether the loops can be like super, you know what I mean? Super tight, so the walls are really close together, so that you have to worry about that kind of thing in the same way we did as day 10. That might not be as big an issue, but yeah, we can for sure follow the way we were doing with day 10. So let me share Advent of Code. Now the thing is, we also learned how to solve day 10 in like 20 ways, so we have to decide which way we want to choose. Why isn't this sharing? 1 second, sorry. All right. Oh, I shared the wrong thing. I'm sorry about that. I don't know how that's possible, but like I couldn't see any of my files. Huh.
Yeah, I suppose you are creating a new share?
Yeah, I'm creating a new share. Sorry about that.
Okay.
Okay. We're in. Okay, I'll create my input. I'll just leave a space for Leandro's.
Thank you.
And then test. That much at least I can do. I like these problems.
I really hope that they are
Cool.
just giving us the easy part 1, because it's easy because we have already done it.
Yeah.
And that the colors will turn everything upside down for part 2.
Yeah. Do you have a way of opening, if you go to this index.html in day 10, is there a way for you to open this in this like VS Code or something? To open this file?
You mean you want me to see the contents, or do you want me to like open it in a browser?
Like, open it in a browser. I guess I could tunnel to you.
Yes, that could That could be the case, yes. Did you do a visualization for day 10?
Yeah.
I remember you mentioned that. Yes.
Yeah.
Let's take a look.
Okay. Allow. Okay. Now I need to remember what the command is to excuse me. Start a server on a particular port, and I need to remember the port that I shared. 8346. So this is the link. Yeah, so this should be the link. I mean, we'll see if it works, but... And then... 8346, 8346.
In the settings in Visual Studio Code, can you say that you want me to be able to see this? Because right now it's only for you. It checks with your GitHub account.
Where do I check that?
Well, when you created the port, it opened a new pane. You know where your terminal is? There is also another pane there for ports, and in there you will find...
visibility private.
Yeah, that.
Port visibility public. Okay. Try that.
Mm-hmm.
Continue. Hey, go to 2023. And then 10. Or, yeah, was it 10?
Very nice.
So that's the plan, I guess.
Very nice. Well done. Yes.
That was pretty long-winded. Well, that was one of the options. So one of the options was diagonal. Another one would be like our flood fill type idea, following left and right of path.
Mm-hmm.
Another would be
Green's theorem is really cool.
Oh yeah.
And it's very amendable to this representation because we are going up and down. So we don't even need to we don't even need to compute the perimeter. We could just traverse this list computing the area.
Yeah. That is and then there was one more, which is I believe somebody just like duplicated everything so that there are no tight walls.
Ooh.
So that problem goes away, and then count it.
Duplicated everything so that there are no tight walls. I don't understand that. What is that option?
So you know how there's like complications come from it being like because there are tight walls, you can't get into the cavities, and there's these cavities which are actually on the outside. So if you duplicate everything, if you spread everything out somehow, then you're able to flood fill a lot easier. You could just need to flood fill from the outside, and then you don't need to like think about left and right of the path and everything else. But I'm not quite. I'd have to like think it through a little bit more to see how the duplication side of it works. And then the last option was like horizontal traversal, but like accounting for the edge cases.
Mm-hmm.
Now Gray's theorem.
Wrong color. It's Green's.
Okay. Yeah, Green's theorem sounds great, but I have no idea where to start. Maybe I will just create the path and then we'll decide.
Okay.
Maybe you can think about which one you would prefer to do. I guess it depends on how hard part 2 is as well.
I see a little twist in this one when compared to day 10. On day 10, we knew the size of the board a priori, and here we don't. So
Yeah.
in terms of allocation and data structures, this is a bit different.
Yeah, it is different. Yeah, that's true.
So in light of this, you can still do the traversal and you will have to dynamically allocate more board space as necessary. Or we could go for Green's theorem that doesn't need that at all.
Yes. Okay, I would like to learn Green's theorem. That's cool. It's a difficult direct way to go down, but we like being difficult. So
And besides, there is no restriction. So because the board can grow, it can grow not only to the right and to the bottom. It could be the case, and it was not the case in the example, but it could be the case that it could grow up and to the left as well, right? And I bet that on the real input, it does that.
yeah.
So
I
we
mean,
will have
you
to
could-
deal with negative coordinates.
I mean, we could start in the middle somewhere, I suppose. But that is an very interesting point. Yeah.
Okay, so I take it back. It's not quite day 10. It's a variation, but it's not quite.
Negative coordinates is interesting. I guess we could like shift everything once we find the minimum. If you see what I mean.
Yeah.
Of the-
Yes. We could build the board
Um,
and then translate it so that it sits in the origin nicely.
Yeah. We could just traverse the path, build the path, and then backtrack and build the board afterwards. Yeah. Okay. Yeah. This seems good to me. Direction string int. Yeah, that's fine. Then color. Well, color is not quite that, is it? Because it's without the parens. Cool. So now I've got my list of instructions. Should we start with 0, 0 and just deal with negative integers for now? Is that going to work fine with Green's theorem? I guess we'll find out.
Yes, I am fairly certain that everything will work out fine. So I start at 0, 0, and now we need to make a decision about how we will deal with the coordinates, because now that we don't have simply a finite board, it may make sense to use more of a Cartesian plane coordinates system where y grows going up.
Rather than row and column. Yeah. Yeah, that's fair. Okay. Wait, growing up. So the inverse of a row. I don't know about that. I think it makes sense to have X and Y the same as a board in case we need that later. Unless we'll run into issues with Green's theorem if we do it that way. It should be fine.
No, I think it should be fine.
Yeah, okay. So let's start node, and then for actually we'll just do like I think I'm probably gonna do I'm probably gonna keep track of the direction. that we're going?
That is not really necessary because each instruction will tell you to take a turn.
Yeah, it will, but won't it be useful later? I guess let's just work to what we have now.
I'm
if we need
sure
it
that
later.
whatever we are going to do later has to do with the color.
Well, I was thinking more even just for this bit, even for Green's theorem or whatever. Like for if we wanted to do the left-right split stuff, we would need to know what the instruction is. So, if instruction I don't want to do that. No, it's just Copilot being silly. In fact, I'm gonna take this out, make this easier to read for me. So it will be plus the distance of the instruction. That makes sense. And then I just need to do the others. Where did the U come from? Oh, no, the others make sense. Forgot about you. Okay, let's verify this. So left is negative x, y, so going up.
So yeah, we are doing the y is going up. We are doing the Cartesian thing. Oh, no, we are not anymore.
Yeah, I'm struggling to make a decision on this. There's so many different ways of doing this. There's also the CSS top left, which is going down like rows. I think I'm going to stick with this, just in case we need to have a thing. Okay, so now we have our paths, and then, but yeah, I don't have a good reason why to do it like Cartesian plane or not. So now we need to find the inside of the path, right?
Well, the way that I understood this is, as we are building, so for instance, let's say that we are going to be doing this with the up and down direction. We could just as easily do it with right and left. But as we are building, for instance, in this line that where my cursor is, we could say that if I am going up, add to the area, and if I'm going down, subtract from the area. So we could just be computing the area as we are going. We don't even need to build a path. We just need to know where we are.
Okay. So this is how Green's theorem works. I remember that in principle, that's how it works. Each time you add a certain amount of stuff. So as we go right, we take it away, and then when we go left, we delete it. Or is it just when we go down?
Well, you can decide. Either we are going to do right, left, or we are going to do up and down.
But don't we need to know the width that we're currently on?
Well, that is our x. That is our x. So we could say that when we are going up, add x to the area, and when we are going down, subtract x from the area.
So when we're going down, we're going to add area plus equals x. You're saying it's this simple.
Yes. Well, there are now the off by 1 edge cases that we have to think about.
Let's just see. It says 13.
Yeah, that's not going to be the right answer right away. I don't think. Maybe it is, but I don't think so. Yeah, we are looking for 62. But there are all the edge cases that we have to think about. And I think that one of the edge cases is just that, think of like one line going up. When we add it,
Schedule?
I think that we need to do a +1 here. And that is one of the off by
Okay.
1 situations. What is the result now? It's still 16? Wait, what?
Yeah, apparently.
This does not make sense, right?
No.
What if I had 1,000? Okay.
No, it was 13, and now it's 16. Okay. Just 13 and 16 just feel like such similar numbers.
Ah, okay, so it was changing. Okay. So that's good. And also, I think that we need this to be the absolute of x in both situations.
Oh, that's a good point.
And
Doesn't change
that's okay.
anything.
It's okay if it doesn't change anything, but I think that that is what we need. And I think that there may need
X
to be a
here is
-1.
just 20.
Yeah, okay. We are getting closer.
We are. So so just to understand what we're doing here,
Do you want to do a shared Excalibur? To draw things?
oh yeah, let's do that.
Okay.
Definitely. Oh,
Can you see me?
yeah.
Okay.
Can I? No, I can't.
Well, I can see you have a bunch of squares.
Oh yeah, now I can see you. Now I can see you. Yeah. Okay, so one way of looking at it is like we move right, move right, move right. We get here, and then we're like, oh, we see a down turn. And as soon as we add down, we add this entire row to our area.
Mm-hmm.
If we go down again, then we add this row.
Mm-hmm.
And then we keep going left, left, right, left, right. Here we don't do anything. If we see an up, here we then take away. I guess we take away that. Or we take
Yeah,
away.
I guess we saw a problem here already. When we are going left, we need to take this in account as well, right? So
Yeah.
I suppose when we are going left, we also add this because we want to catch this last line here.
Or do we just, when we go up, we need to. Well, yeah, I guess it's like. Unfortunately, it's not a great way of erasing this. Oh. Yeah, so if we went down here, we would be adding this, which would make sense or wouldn't make sense.
It would, because this is interior. I like that.
Yeah, but wouldn't we have missed on this other little bit here?
Can you point me at the squares we would be missing?
These ones?
Yeah, so that's what I'm saying, that we are missing this last line when we take the left turn. So what I'm thinking is that maybe we just need to add an area plus equals x when we take, for instance, a left turn.
I feel like there's going to be a lot more cases, but should we just try it? Or should we...
I'm trying to be principled about this, because then if I'm doing something when I turn left, I should be doing something when I turn right. I don't want to think about the turn. I want to think about the fact that I have visited this line. So... I'm having a hard time thinking of this in terms of what is the code that we need to write. But the intent is that I have visited these 3 lines. I will want to add x 3 times. So how do we add x 3 times in a principled way that doesn't lead to a lot of churn in the code?
Also, it assumes that the cycle goes back to the start, doesn't it?
Well, that's a guarantee.
Okay.
We are doing a loop. Otherwise, it wouldn't even make sense to ask about the area, because it would be an open shape. But it is an off by 1 problem, even, right? We are off by 1 line. And right now we are capturing this line and we are capturing that line. So maybe what we could do is have the previous direction with us, kind of like what you wanted. Because then if the previous direction was going down, then we add x.
Yeah. Because if we did like... Oh. I'm so bad at drawing.
Oh, and there is another problem. There is another problem. No. Forget everything. Forget everything. Forget the whole discussion thus far, because we made a fundamental mistake here in the way that we coded this. In the way that we are not going step by step. We are going in one line, or in one instruction, I should say. In one instruction, we are going down 3 times. So we should be multiplying the length of our step.
Yeah, that's true.
Yeah, we are dealing with rectangles. So when we are going down, we need to take the absolute value of x, multiply by the distance.
Yeah. That makes sense.
Now, again, there will be all sorts of off by 1 mistakes here. So I will let you elaborate on the idea.
Well, I can do this much. And I can see what the output is. It's 49. That does make a lot of sense, though, that we needed to multiply by distance. Good catch. I'm not sure about...
These plus 1s and minus 1s, I think, should be with the absolute values and not with the instruction distances. So I guess what I'm expressing isn't super clear. I will try and type it. Let's see if I... Oh, no. Okay, you are doing it. Yeah, that's not what I meant. That's not what I meant. I will try and type what I mean, and we'll see if that makes sense.
Not sure why we need the off by ones. 60.
And we are getting closer to the expected answer of 62. Well, okay. So we have found one major problem. Now there is all the off by ones that we need to reason about. My thinking is, back to Xcoli Draw. Suppose that we start here. And then we start by going down. And then we take a left turn and we go back up. So this is the loop. And let's say even that this position here is 0, 0. So we started at 0, 0. The area here in this figure is 6. And I started at 0, 0, so I'm going down. And the direction, the instruction will be go down for 2, go down for 2 blocks. And I want to capture this much.
Yep. But you need to capture 3 in a way.
Yeah, so it's distance plus 1.
Sure.
So there is, back to the
But
code
is that
here.
distance? No, but is the distance?
So there is a plus 1 in the distance. And now, so we need...
Is it distance plus 1?
I suppose, right? Because we go down 2 steps, but we want to capture these 3 lines. So it's distance plus 1.
Yeah.
And coming back up, we want to account for these blocks as well. So because we want to account for these blocks even on the way down, then we don't want to use 0, which is our coordinate. We want to use x plus 1 to account for this square. And maybe we don't need the absolute values after all, because on the way back up, we will be dealing with x minus 1, but we will want to add.
I thought we were meant to always add on the way up and take away on the way down. Or vice versa. Add on the way down and take away on the way up. So like maybe we should be...
I suppose when you are dealing with the negative part of the plane, things swap around. Yeah, I think that we don't need these absolute values after all. And do we need this minus 1 though? We'll be dealing with position negative 1. Minus 1. I think we may not need this minus 1. Just out of curiosity, can you run this? 67. Yeah, we are still not there. All the negatives are making my brain hurt, so I am going to...
Why do we need the plus 1?
I'll try and convince you that we need it. Let's see if I am able to. I am going to draw another path that will start by going to the right, then going down, left, and up. So we start at 0, 0, and we go up to what I want to call 2, 0. And then we go down to 2, 2. Left to 0, 2. So when we get here and we go down, there will be a down instruction of 2 steps and we want to add 9. So that is the distance plus 1 times the x-coordinate plus 1, which we have right here. Distance plus 1 times x plus 1. All of that looks nice. Then we go down.
Why x plus 1?
Because we want to account for this box as well.
When is this when we get to this down here?
I don't see your cursor. Your cursor seems to be in the middle of nowhere.
Yeah, sorry, I was looking. It was on Skype.
Okay.
So we get here, we don't count anything. We're at 2, 0. We go down 2, so we want to add these 3 multiplied by these 3. So we add 9 at this point.
Yes.
But now we have the full area.
Yes.
When we go back up, we don't want to take anything away.
We don't want to take anything away. So this will be, when we are going up, we want to take away 0. So when we are going up, we want to take away instruction distance plus 1, and we want to multiply this by 0. So I would claim that for my input off, go to the right for 2, go down, go to the left, and go up. I would claim that we get the right answer of 9. Can you run this?
Oh, this makes sense to me, yeah.
All right.
9.
So next, we have to deal with the case of when we have to subtract something. Which would happen if we had a path like this. In this case, the answer should be 8. And we will be adding 9 when we come here. And here we already know that we are not subtracting anything, but here we need to subtract 1. So this is coordinate 1, 3.
Does it not make sense in terms of building this up? Hold on, let me draw something else over here whilst you keep going. I just wonder whether it makes sense to check that this one works and that this one works.
Okay. That's a good call. I will come up with the inputs for those. So your first square that you drew, this one, is going right, then up, then left, then down. So right, then up, then left, then down. Can you run this? We get minus 3. Let's see why. We are going right and then we are going up. So here I expect to see... Wait, what? Did I do the right inputs? Right, up, left, and down. I did the right inputs.
Yeah.
And we are going up. As we are going up, we should be adding to the area, in this case.
I guess so. Or maybe it doesn't matter. Like, as long as we go up and then we go down in one direction or the other, I would have thought it should be fine, as long as they're symmetrical. But they're clearly not symmetrical.
Your mug is transparent.
Oh,
It was
really?
transparent for a moment, now it isn't anymore. It is interesting. It has to do with the direction.
Should we look up Green's theorem? Because I never really understood it. It was always, it's kind of, is Wikipedia the best place?
Maybe not. Khan
Academy is pretty
fine.
friendly.
Yeah.
I mean, for dummies like me. Let's have a look.
I am loading the page. Okay. The clockwise versus counterclockwise is important.
Okay.
I really wish that it would just give us a negative area, but the correct area. Yeah, that's the kind of the intuition that I had.
What's the intuition?
That if you are going up, you add, you are going down, you subtract, then the going up is going to overcount because there would be extra x's here to the left, but going down, you're going to cut them out.
Mm-hmm.
Yeah, the problem is that it's using all this notation for calculus that I find disorienting.
Yeah, same.
But really the key seems to be that the orientation was given in the beginning. Part of the setup is knowing that you are going to do a clockwise motion. And in our case, we don't know that a priori. We only know when we arrive in the end that, oh, we were doing this clockwise to begin with, or a counterclockwise to begin with.
Do we know whether it's clockwise or counterclockwise?
Only at the end, right?
Yeah.
So maybe we could accumulate both areas, clockwise and counterclockwise, and when we get to the end, we check, were we clockwise or were we counterclockwise, and then do output one of the two.
Like, how do we even check? It's like, yeah, we went clockwise, but couldn't we have gone like... I'm trying to think of a counterexample where like it looks like that, but it's not that.
How
Maybe
can we?
something
Yeah, that's an excellent question. How can we determine that a path is going clockwise or counterclockwise? Because it can fool you in these ways.
I mean, maybe this isn't a very good thing, but I mean, we can work out whether we're going left or right. And if we have a negative answer, we can just run it the other opposite direction. I mean, does that work if you were to...
I suppose one
So
of the
can I-
answers is always going to be negative. So let's
Yeah.
try that idea.
But if we try that here in the code, if instead we went up 2 and then right 2 and then down 2 and then left 2, does that give us the right? Yeah, so that gives us 9. Yeah, so one is -3 and the other one is 9. So one is correct and one is wrong. I mean, we could just do it that way, I suppose.
Yeah, we could just check which one is the maximum.
Yeah.
Can I flash
then
this
I
out
guess-
just to see?
Yeah.
Okay, so I'm gonna call this the area, and I will say that this is clockwise. And the other would be the counterclockwise. So then in the end, we are going to print the max between these two. And I suppose that the only difference is that. What we get now.
Yeah. I mean, now we do get 9 for that one, although I changed the example. So yeah, now we get now it works. Now it works.
Does it work
So-
for the example input from Advent of Code?
Oh, I don't know about that. 67.
So not yet. But there is a chance that we fixed whatever was wrong with the counterclockwise situation that you brought up. So I think that all these 4 squares are going to do the right thing now.
Yes. Should we do an example where... Let's do one of this example that you did up here.
Yeah. So in this case, we want to exclude this. And we are at x is 1. So when we are going up, we don't want to do the +1 in the direction. And we don't want to do the +1 on the x either. Can we try that? On the real inputs.
70.
I made the problem worse.
But does that even work for the test inputs now? Oh yeah, that still does.
I suppose
Somehow.
let's test this case and see if we get an age.
Don't you have to... Yeah. Should I do the input for that? So if you read it out, it's going to be right 2,
2, down 2,
down, then left 1,
left 1, up
Up 1.
1, left 1, up 1.
and then 8.
Okay.
That's nice.
Um,
You didn't change any of the code, did you?
I removed some +1s from assorted places.
At some point. Oh yeah, you removed a +1 from these ones.
Yes.
Why?
Because here we don't the distance of this move is 1, and we don't want to take this out as well. We only want to take that out.
Yeah. That makes sense.
And
Okay, so we're getting 8.
we are getting 8. Next, I think we perhaps should think about the negative space, because maybe we do need the absolute somewhere. I removed the absolute, but it may be necessary. So I want to think about perhaps even this example to see if we get the right answer.
Yeah, sure. Do you want to read out the input and I'll type it?
Okay, left 2.
Left 2.
Up 2.
Then, yeah. Right 2.
Right 2. And down 2.
Cool. 7.
That is wrong. Should have been 9.
Yeah, that's very wrong.
So where are we going wrong? We are going to the left, which doesn't add anything. Then we are going up. And when we are going up, and we are in this one going counterclockwise. So, or are we? No, we are going clockwise. We are going clockwise. So in this one, we are going up, and we want to subtract. Well, x is negative. It is -2. But in this case, I kind of wish the distance +1 was here.
Yeah. But also then we would be 3 off, because like, in the case when we're going along the x-axis, we want to take away nothing. But that doesn't make sense to take away nothing. I think we should always be taking away something and adding something, because it's only the special case of when we're on 0 that we don't take away something. It feels like area is kind of independent of whether we should be on the 0 axis, and we have that special case. I feel like as we travel down, we should double the amount of area, and then as we go up, we just take away half of it. Do you see what I mean?
No, can you explain that some other way?
Like, I think we should overshoot when we count up. Like, when we go down, we should be overshooting the amount of area that we're capturing. Because as we go up, we should be taking away half of it.
Can
And
you
if we
perhaps
take
draw that for me, because I don't see it?
Yeah. I mean, it's just a crude idea, but like, so here we're going along, and then as we go down, here, at this point, we should be counting, like, not just exactly what the area is at this point, but like double this. Like all of that. And then as we actually come back here and up, then we delete this from our area.
What's the point?
The point is that there's no like special case of like the 0 axis. Like this is the 0, right? Where we don't want to remove any area. We should always remove the right amount. We should always be removing area, overshooting and removing as we go up and down.
I still don't see that. Perhaps you can show me with code. I don't know. I'm thinking of other ways that you can explain this to me, because I don't see the problem and I don't understand how your solution addresses the problem.
Yeah, so the problem with the 0 is like the way that we built it is that, so this is the 0, 0 here, yeah, of the graph.
Mm-hmm.
And then if we have, the way that we built it is that if we travel up the 0, we're not taking away anything from the area. And that's how we end up with the correct area, but only by virtue of it being on the 0. If we had a box which was just like offset a little bit to be here, it's not going to work, because we're not going to take away nothing as we go back up the 0 axis.
Well, this box that you drew doesn't really exist in that way. It exists only in this way. And my claim is that our algorithm works for this, because we would be over counting this portion on the way down, but then we would be discounting that portion on the way up.
That's true.
Undo is now working. Good job, Xcode job people.
No, it's so flimsy. I've tried it a few times today. Yeah. No, that's a good point.
Yeah, now our problem, I guess, is this orange case over here that is an off by one mistake. It's still an
Maybe we
off by
do
one
need to-
mistake.
Well, maybe we do need. We do need it to be in like positive values, otherwise it won't work for some reason. So what happens when we're going up is we're like taking away. Yeah, but we've got this clockwise, anti-clockwise thing going on, so it should be doing both.
Yeah, there are two cases that are going clockwise. I guess I will draw them in a separate grid. So let's get a grid here that is a bit larger. And this will be our origin. And there are two ways for you to do a clockwise motion. You can do it like so. And you can do it like so. In both cases, it's clockwise, and in both cases, we have an area of, well, not in both cases, we have an area of 9, but we are about to. And what is interesting about this too is that this is going to the positives and this is going into the negatives. Oh, no, no, not really. We are not doing it this way. Our plane works differently. Did I get it right this time? I think I did.
So they're both clockwise.
They are both clockwise. One is going into the
But one's
positives and one is going into the negatives.
Mm-hmm.
So let's think about all the plus ones and minus ones and absolute values and blah, blah, blah that we need to think about. And Sarav is here. Hello. Can you explain how to shoelace the first part? I am not sure what you mean. Can you ask that in some other way? What do you mean by the shoelace? Is this the perimeter that we are talking about or something else? Okay. Let's think about this one. As we are going down, x is equal to 2, the distance is equal to 3, so it is x plus 1. No, distance is equal to 2 as well. So it's x plus 1 times distance plus 1 and add that. And on the way back, you don't have to worry because x is 0. So don't add 1 to x. Over here, x is minus 2, and I will need to write that down because then it gets complicated. Like that. So we are at x minus 2. And we want to add 9. So it is minus 1 So I guess it's the absolute value of x plus 1. For instance, we are doing a clockwise motion and we are going up. So we want oh shucks, we want to add 1 here. That's our intent. But if we do that, we're going to break the other case. So there is some small trickery here for this plus 1 that I'm not quite getting. Do you see what the trickery could be?
No, but I'm tempted to just Google like Python Green's theorem to see how.
I think if you do that, try that, because I think if you do that, you're going to find a bunch of things that are related to calculus and continuous shapes and integrals. And we are in a discrete case, which is in principle the same, but it looks very different implementation-wise.
I mean, this one doesn't seem so bad. I can send you this link. This link looks pretty good. Area of cross section. You know, it's got, if you just scroll down to the code. We could at least review the code, see what it's doing. It's like, there's a bunch of points, and then it just goes through the points, and then it does some maths, and then it returns an area divided by 2. We could, seems like that could work for our discrete case.
First, like parsing the Python.
Yeah. So the first one is like, make sure the first point is not equal to the last point. Or if they're not equal, then it adds an extra one to the end.
Ah, okay. So that's just to close the loop. I get that part.
Yeah. Then it just gathers all the x's and gathers all the y's.
Mm-hmm.
And then for each one, it multiplies the x by the y plus 1. And then takes away. So I don't know why you would do that. But you multiply 1 point, and then you get the next point, and you take away that one's point from this point somehow, for some reason.
So they're not doing it like line by line like we are. They're doing rectangle by rectangle.
That makes sense.
That kind of makes sense to me, yes. I wonder if that is the key for this part. Well, let's really think hard about these indices and see how they pan out. I'm going to copy this line and I'm going to paste this line here and really think hard, stare at this for 5 minutes until it starts making sense. I is our point in time, right?
I can't see it at the moment.
You removed it.
No, I didn't. I think it's just like stacks for internet or something.
I did it again. Do you see it now?
Nope.
Do you see it on my screen, on the screen share on Skype?
Yeah, I see it on the screen share. It's alright, I've got it.
It's gone again.
Here. That's annoying. I'll paste it in then, in that case. Maybe I'm the author of this Excalibur and nobody can stop me. Can you see it?
No.
I've done it?
No, our Excalibur draws are out of sync. Oh, now I see something.
How about that?
Okay. So I is our point in time. So for instance, if we are here at this point, I will have to draw, or I guess if I start drawing, then I will lose my changes. So can you draw the numbers of the coordinates for this case in which everything is positive and things are easier to reason about?
Yeah, so this is 0, 2.
Thanks. So if I is this point in time where my cursor is, then we are taking this 0 times 2 and we are subtracting this 2 times 2.
Wait, is it? Yeah. Yeah.
Why are we doing that though? We are looking at this square and we are subtracting this square. No, we're not even looking at that square. We are looking at this square. And there is again a bunch of plus ones, minus ones to deal with. Oh, shucks. Perhaps this idea of implementing Green's theorem was bogus after all. If we had done the diagonal thing, we would be in part 2 already. Just because of all these plus ones and minus ones that we have to think about. They are a nightmare.
But there aren't that many plus ones. The plus ones is just saying like the next point in the path.
Yeah, these plus ones are just the next point in the path, but in general, these coordinates need a lot of plus ones, minus ones to work out. Even here, our problem is still a plus 1 that we wish to put, but we cannot because it will break another plus 1 in another place.
And it's weird to me that there's a like the area divided by 2 at the end. Like maybe my idea over here was like a fluke, but it was correct. Yeah, I don't fully understand why you would take the y of the next one and your x and take that away from the x of the next one, but your y. Like you're kind of like mixing points.
Yeah, this is rewriting the loop in mathematical terms.
Is it worth checking if this is correct? Or just running it with our code? Or should we just abandon this idea for now and come back to it another time when we have a clearer brain? I'm tempted to try it because I want to see if it actually works.
Yeah, can you flesh this out?
Yeah.
Oh, you're just literally taking the area. Okay. You're just literally taking the code and seeing what it does.
Yeah, and then I can just be like, oh, sorry, I'm getting a call. Let me delete that. And put my focus mode on Do Not Disturb. And then I will just say points equals like that. And then print area points. So we get 4 for 17. I guess that is
the
wrong.
fact that we get 4, no, it is right. The fact that we get 4 is an off by 1 mistake. Again, because of course, off by 1 mistakes all around. But it's just counting these 4. So it's off by 1 because it's not counting all of this exterior. But you could just add the path. No, that's not going to work either. Don't add the path. We could just plus 1 in assorted places. Not like that. What is the output of that?
It's still 4.
Yeah, because you're just translating the whole figure.
Oh yeah, of course. But we could, I guess, add.
5, 6, 7, 8. Not even that.
Well, if we did in distance +1 here, then it might. Yeah, then that works. And then I suppose this would work as well.
What? What are you doing? What's happening?
69.5. Not quite.
What did you do?
I just changed it here.
Ah,
That's the only. So that would mean that it's like everything's just slightly bigger.
ah.
And it did work for that case, but it doesn't work for the general case. I guess we have two choices. I feel like I don't fully understand Green's theorem well enough to be able to implement it. And I feel like you're going down the route of deriving it from first principles, taking the basic concept, which I'm very impressed with, but that could take us several years. Or it might not. We might be very close. I have no concepts of that. So either we continue down that, which I'm up for doing if you are, or we use a strategy which we know we can get the answers for.
Yeah,
What's your feeling?
I suppose Green's theorem is probably the most principled solution, particularly because of the way the problem is structured with directions and stuff. But that's not where the light is, because Green's theorem entails a lot of +1s and -1s and off by 1 mistakes, which will also be the case for the other algorithm, but at least on that other algorithm, because we have a better grasp, all the +1s and -1s, which seems to be a theme, right? Yesterday we were also like, oh, +1, -1, oh no. Yeah. Anyway, at least there, the light is there, and we will probably be able to do this. So I guess let's just forget about all this area stuff and
Hold on.
use the path that you constructed to do maybe the diagonal argument, which you already implemented.
Yeah, let's do the diagonal version. I'm saving this file, the copy, as Green's theorem, and we can maybe come back to it at some point. How about that?
Yeah. And it's nice that you are already constructing the path anyway.
I don't think the diagonal one, we really care about the direction of things. Do we care about the direction of things? I think we do care about the direction of things.
No, in the diagonal one. So here's how I think this goes. When you are constructing the path, let's also accumulate what is the smallest x and the biggest x, the smallest y and the biggest y that we see. Because like I said, we could be going to negative coordinates. So let's accumulate the mean and the max of x's and y's so that we know what is the bounding box of our shape. Then apply the diagonal argument that you have already implemented with the visualization and everything. Just apply that diagonal argument to this bounding box, and that's the area.
Yes. So you think first we need the board. That makes sense. Yeah. Okay. So that's the minimum x. I think we want it to be like starting at 0, 0, right?
Yeah.
So.
And the same for y, right?
Yeah, so we want to offset everything, create a new cell. based on that offset.
Ah, okay, you're thinking about this differently. You are thinking of translating the board, right?
Well, if it's going into negatives, I don't want to deal with negatives. So I was thinking, just make sure this is positive, and then we can deal with the board, and then we can work that out. I mean, it's not actually. I don't actually think we need to have a board for counting the area, which is probably what you were just saying just now, which is absolutely fair enough. Yeah. Okay. That is true.
No.
So we
okay, what I was trying to explain is different. We are building a path. This path may visit negative spaces of the Cartesian plane, right?
Yeah.
And I guess even if it doesn't, even if it's only on the positive part of the Cartesian plane, it's still the case that we don't know the size of the board. So if we were to apply this diagonal argument, we don't know when to stop. We don't know the boundaries, right? So my proposal is, let's find the bounding box of the path.
Yeah, we now have that.
We don't. We just have that for x. We need the same for y.
Oh, sorry. Thanks.
That. And now we can do it in two ways. We can translate the coordinates of the board. So every coordinate or every cell, as you call it, that we have built so far needs to be translated or moved so that everything is in the positives. Or we don't even need to do that. We can just start applying the diagonal algorithm. Well, not 0 and y. It is more like min x.
So I'm thinking to get all the cells of the board. So this is all of the ones on the left. So we're going get the first cell, traversing not from the min y, but from 0 to... Oh no, from the min y, yeah.
And this is not 0 either. This is min x, right?
That's a good point. Yeah, thank you. And then this will be max y.
Mm-hmm. Yeah.
That's good. And then we're going to create diagonal rays. From that X, from that cell, going up and to the right, and then we will do our algorithm. Now, actually, I'm just wondering if we want it to be inside or outside. Let's say that the state, let's get the char, is equal to
I just thought of something. For my
What's that?
For my work in progress implementation of Green's theorem. I think that what I was missing was simply like, if I am in the negative planes, do the +1. If I am in the positive planes, don't.
Do you want to try that?
No, continue.
Um, so, if it's in the path of set, we'll say the state is inside. And we're going to have, while the cell is cell dot x.
Can you explain
We're gonna-
line 289 for me? Convince me of what's the point. I don't really get it.
289 or 789?
789, yes, 789.
We might need to do this in a second. But basically the idea is we're going to be alternating from inside to outside as we pass through lines of the path. There are some edge cases which we're going to need to account for.
But my question is, I will phrase it another way. My question is, why is the state potentially inside to begin with?
Because the path could be on the border.
Well, I say two
it-
things about this. The first is that if that's the case, we are about to see the path and go inside. So that's all right. But even if that weren't all right, then I would say, let's just say the mean x minus 1, max x plus 1, mean y minus 1, max y plus 1 on these lines.
Yeah.
So we don't have to deal with this part of the problem.
Yeah, let's do that.
But I don't think
We'll need to do this at some point anyway. But yeah, I agree. Let's just do that to make this a little bit simpler.
But I don't think that is even necessary. You can always consider that you are on the outside and then step in to the first cell. And then you're going to realize that he is in the path, so you should go inside.
I'm not sure. I haven't thought about that part fully yet.
Okay.
I will get there. I just want to like do the traversal of the diagonal rows of the diagonal rays, and then I'll get to the state stuff in a sec.
Okay.
So while the cell X, I can now change this to out anyway. While the cell X is I think I might just make this simpler for me and just do inbounds, because that just like makes my life simpler. So while it's bigger, while it's inside, that makes sense.
Mm-hmm.
And I can just do this.
Mm-hmm.
Don't really care what the Copilot's suggesting there.
Hmm.
What I need to do is next cell, or probably just cell. Let's call this edge cell. And then cell equals edge cell. And then, I mean, it probably doesn't matter, but cell equals because we're going up.
Well, so
Yeah.
this way we are casting the rays left to right and going down, right? We are doing a diagonal like that.
Oh yeah, because I forgot how we were doing this.
Which is fine. Whatever, right? Doesn't really matter.
It does matter because that's not how I've done this. This is getting the bottom left.
It's getting the bottom and the lefts. So you want to cast your rays going to the right and up. So it is plus x plus
Yeah.
1, y minus 1.
Yeah. You're right. That's cool. So now we know we start on the outside. And we need to get the is path cell. If it's a path cell,
Then flip the stage. Yeah.
and we need to count it here.
Mm-hmm. It doesn't need to be a set. It can just be 0 and add 1, right?
It could be. I'm going to add them though, and then we can print the length. I think that's fine.
Okay.
If it's a path cell, we can simply do insiders.add cell if in, otherwise out. Yeah. That makes sense to me. Now,
there is an off by 1 mistake here. No, there isn't.
There are a couple.
No, there
couple.
isn't, because of the way you constructed. I guess there is. Because you're about to step into the path, okay? So you're outside, you step into the path. Your current state is, I am out. But this is in the path. It should count as an insider.
Yeah. So let's go to I know that there's two important things. One is that we need to account for traversing corners separately. They are edge cases. And we need to think about them differently than other path cells.
No,
So
that's
we will
what
go-
the diagonal is for.
I mean, I wrote the diagonal algorithm, and I initially tried to write it without this. So let me see if I can prove you wrong.
Okay.
Or not prove you wrong, but like make you agree that we need this. This might be enough. Yeah, this could be enough. Can you see where I am in Excalibur?
I am. Yeah, I'm there. I can see you.
Okay, so this is our square.
Mm-hmm.
And then
This is the path.
our array. This is the path. It's too small, isn't it? We need to have something inside the loop for this to be worthwhile. I just add an extra column and an extra row. Okay, and I can draw this. So we need to count this guy inside here. So here we start on the outside. That's fine. There's no issue there. Here we start on the outside. Then we haven't changed, so this is also an outsider, so we'll mark that. Here we start on the outside. We go here. We should count this one as an insider, but we don't in the current code because oh no, yeah, we don't because we haven't changed to inside yet. Well, I guess we don't need to actually mark these as insiders necessarily because these are on the path. But okay, so here we change the state to inside, and then we would mark this. Let me just change this to green, and I'll mark insiders as blue. So what? Here we would change it to inside, and then we would mark this one as blue incorrectly. Right?
And by blue, you mean green in this case, right?
So green, I'm saying outsiders, and it should be green, but it's blue. Actually, let me keep it as the same color as this should be. Like we would mark it as red because we've just traversed this point, but we actually shouldn't do that. And equally, if we start green here and we hit this corner, then we're going to say inside. Then now we're inside, we mark this as inside. Then we hit this one, so now we say we're outside, and then this works.
Okay.
You see?
Yeah.
So the corner points are important. Specifically, the way that helped me understand it was with a circle. You have like a few lines. You have this one, you have this one, and you have this one. I suppose you have that one. Or yeah, so this one, you can see it will cross in 2 points. It will cross here, so now we need to say inside. And then when we leave, we go back outside. This one is on the tangent, and because it's the tangent and we know that it's going to leave immediately, therefore we shouldn't count it.
So how do you do that? When building the path, you count this as special, or when you are doing this traversal, you look not only at the node but also at its neighbors?
So I think what you need to know is this tangential point. So this point here and this point here are tangent points. And so therefore we don't change the state if it's one of these tangential points. Whereas for this point or this point, we do. Because we're traveling from the bottom left.
Yeah.
Does that make sense?
That does make sense.
Okay. Cool. So I'll have a go then. Well, what we need to store now is the direction, right? So what I'm going to do is I'm just going to change. I'm going to have a new one, which is a node, for want of a better word. And it's going to have direction in, direction out.
Oh, wow.
You don't like that?
No, it's just that this implementation is getting complicated. And there is another thing. We are going to revisit line 772 down to 782, right?
772 to 782. We don't have to be honest. Like, we can just, like, we've got our path as a list of cells. Now we just need to add those directions. We could do it that way.
You can do it that way if you wish, but there is one thing that I want to point out about these lines. We are only appending the cells at the corners. We should be appending the cells along the way. I'll try and explain this in some other way using XCollyDraw. Coming back to your drawing. We are here, and we say, go to the right for 2 squares. In our code, we implement it in such a way that we are keeping this, and we are keeping that, but not this.
Yep.
We need to change that.
We need to change that because, oh yeah, our whole path thing depends on that. Yeah. I mean, we only use path as set here, so we could be smart and not do it that way. But let's not do it that way. Let's just do it like this. Do you agree with that?
I'm thinking of the off by 1 mistakes that could happen here. So if we are going to the right for 2 blocks, like we are in the XCollyDraw drawing from where my cursor is to the right for 2 dots, I want to add to my path 2 squares. So my distance is 2 and range is non-inclusive. So it's I is going to be 0 and 1. Then I'm here and I'm going to append to the path x plus 0. What is this plus 1 about?
Because if you add 0, then you're just going to add the same cell.
Ah, I see. All right. I agree with what you wrote.
Yeah, good spot. Now we need to do the direction stuff.
Can we change the ranges instead? No, it doesn't matter. The code is going to do the right thing. I was going to say just change this range to go from 1 up to the instruction distance plus 1. Whatever.
So we have the path. We now need to create nodes instead of cells. With the direction, I guess we don't need the direction in and the direction out. We just need the direction out. And then we can infer the direction in by looking at the previous node in the path. But it might be helpful to just have the direction in and direction out stored on it. I think I can only truly do that.
I have another way of going about this. Can I propose that to you?
Sure.
What you are proposing now is to
So
go over the path again and make sense of the directions and all of that. How about, let's come back to XCollyDraw. How about we go over our path and filter stuff out. Specifically, we are going to filter out this kind of edge and that kind of edge. And to find that we have one of those edges, all we got to do is look at the path for each given element. Is my preceding element with the same y and x minus 1? And is my subsequent element same x but y minus 1? If so, remove myself. Just filter out the set that way. This way you will end up with a set of path elements that boils down to these guys.
Yeah. Okay, I like that. So path without bottom right.
I love the
And-
variable name.
Top left. That's not what we want. If cell. No, let's just do this. Hmm.
Mm-hmm.
So, I guess is this going to work? Yeah, because -1 will just work in Python, which is nice.
It is nice.
So get the previous cell and the next cell. If we can't move diagonally, so all we need to check is that
I had another insight. How about when we are building this up? So on these lines, okay, we are figuring out the path. If it is the case that
the previous was up, yeah, we can just do it there. Yeah.
yes, and then we just manipulate the ranges to not include this guy in the first place. So what we are interested in is if we are going right, we were going right and then up, or if we were going down and then left. And similarly, up and then right, and left and then down.
So I'm keeping everything at the moment, but if prev instruction equals down, bottom right is down and left, and
Right, then up.
instruction
What? That's not what I imagined at all. Can you explain this to me?
yes. One sec.
Mm-hmm.
So I just decided to not like nuke all this code for now
Mm-hmm.
because I kind of want to have the whole path available to me.
Mm-hmm.
So I keep track of the previous instruction, which I'm not doing yet. And then I just keep appending everything to the path as I would before, except if the previous instruction was down and now I'm turning left, then I must be at a bottom right. Oh, no, so I should actually be doing else this, and then I mean, this is redundant code, but pass. I'll refactor in a second. But yeah, so if this is a bottom.
Are you trying now to accumulate the top lefts and bottom downs and bottom rights?
Everything else?
So you don't want to append just the path -1. You want to append this whole range that we have added.
Oh yeah, I forgot about that. Forgot we were appending ranges now. Yeah, we need to just not append that actual corner cell. That's kind of annoying.
How about we just detect that we have a corner cell? And wait a second, how do we even know what the next is going to be? Oh, because we are the next. Okay. How about you just store all the bottom rights and then and the top lefts, and then we do a set subtraction in the end.
Sure, I just need to make sure I like... So the cell, which is the bottom right or the top right. So if it's... Yeah, I see why you've said that, because it's quite easy to... So we'll just call this the... bottom rights and top lefts. And if is bottom right or is top right, then we need to add. No, because I still need to. I kind of just want to separate this. Is the last one guaranteed to be?
Right. We could have a problem at the edge again.
Wait, couldn't we, if we did this above? Isn't it just last cell? Like before we add this stuff?
Well, I am trying to make sense of what you wrote, step by step. So the first step is that this is missing another case. You could have a corner because you are going down and then left, but also because you are going right and then up.
Yeah, that's this case.
No, this is the case of going up and then right. I said right and then up.
Yeah. Right. Oh yeah, that's very good. That's a very good point. Thank you. You happy with that?
And I think the variable should be called is top left.
Yes, thank you.
Okay, so you're going up and then right, or left and then down. Now I'm happy. So if it is either of these two, append the last cell. Now I'm happy about everything I see. But there is one extra thing we have to think about, which is when we wrap back around to the beginning, the very first could be one of those special cases. It could be a bottom right or a top left. So we have to deal with that as well.
Yeah, that's why maybe it would be nice if it was a secondary step where we store all the directions. But in that case, the previous instruction...
Wait a second. No. That case is accounted for. That case is accounted for. If let's come back here to Xcoli draw for a second. The problem that I'm bringing up is that this very first cell could be top left. And in this very case, it is. So we will take this one direction at a time, one instruction at a time, I should say. We will take this one instruction at a time. When we get to the end, we will account for this being a top left. So it's all right. We don't have to do anything special. It's already accounted for. The set already includes everything that it needs to include.
Is that because the last cell is the first cell?
Yeah.
But the thing is, we only append the last cell. Always. Which is the cell, the previous cell. Maybe I'll call this proof to make it more consistent.
Ah. And then that's going to be a problem because the previous instruction is none. So how about instead of adding the previous cell, we talk about... Well, that's not even right to begin with. You have just done a bunch of things to realize... No. Ugh, wow. This is such a simple problem. It's such a simple problem, and yet it's giving us a headache. It's like yesterday.
So yeah, I mean, this is just saying, like, this is a new direction, right? Like, this is a corner.
And against the time axis, that is the problem. Are we just taking a corner, or have we taken a corner in the previous step?
Yes.
The most fun part is that this is a simple problem. It's giving us a headache. And we have implemented this before. You have even an animation that does this, which is much more complicated. How come?
Well, it's just a slightly different problem, isn't it? And we're only on part 1, remember?
Yes.
Well, maybe we wore ourselves down by trying to do the extra clever route with the green serum, but it was a fun detour, and it might be useful in the future anyway.
Yeah.
But so we just have to handle this edge case, which we can. I mean, the stupid way would just be to copy this and paste this code, and just run it for the first.
Copy and paste
one,
which
right?
code?
Just this.
Ah.
And
But
just
now I
move
have to
this.
reason about this again. Remember, I was reading your code and I was bringing up all these details here, but I was under a wrong impression. So I have to rethink from the top what it even means, all the things that we are doing, what that even means. Because I was thinking about it the other way around. I was thinking that when we arrive at a cell, we would reason, like for instance, coming back to XCalibur, I go to the right. Should I add this as a corner or not? And then I go down, should I add this as a corner or not? But no, what you're doing is, you are here, and you're about to go down. Should I have added this as a corner or not? So on the temporal time, I am off by 1. And in light of this mistake that I did, I need to rethink this. So my previous instruction was to go down, and now I'm going to the left. So it means that in the temporal axis, I am here. My previous instruction was to go down. My current instruction is to go to the left.
Yeah, and the previous cell, when you're at that point, is on that corner. Because that's where you are at that point, right?
Mm-hmm.
Before you've added these new cells. So you're on that corner cell. You're determining whether...
So here's something we could do. When we look at the instructions, we could add the first instruction to the end of the list.
That would be nicer than what I've done, which is pretty ugly. I've just copy and pasted that.
As long as it works,
Yeah.
I'm happy.
Yeah, I mean, we could abstract this so that it's like a function, so it's easier to read.
No, I'm happy
But
with
I
the
think-
copy and paste.
Yeah, and it's like this is just the previous instruction, which will continue to update. And now we just need to check that this direction of this instruction, because it's just that when we run it the first time, the previous instruction is going to be none, or null, or nil, or none. And here we just need to run it one more time. And I just changed instructions 0 direction.
And then we append path of 0. Okay.
Is that right?
Yes, that seems right to me. Or
Okay.
maybe it isn't. It should be path of -1.
No, I think it should be, well, we're determining if
Because of these
That.
+1s that you put here.
because of the +1s I put there.
Because of the +1s that you put here. Because
Well,
think now of the first case, okay? I have just landed on the board and I'm about to start drawing. I will go to the right for 2 steps. In your implementation, we are adding this fellow and that fellow.
Yep.
So
But we've already added the first one as well. The first one's already on the path, but yeah.
wait, what? How so?
Look at
Because
this.
of this line.
Yeah.
Okay, so in the end, it doesn't really matter because it's in the beginning and the end. Your path already includes cell 00 in the beginning and the end, guaranteed. And besides, even this could be just cell 00, right? We know that we are in the
Yeah.
origin. Okay, we
Yeah.
are in agreement. Carry on.
Cool. So then what we need are path as set without top.
No. We said bottom rights and top lefts, not top lefts and bottom rights. Oh no.
It is without top lefts and bottom rights.
But
right, isn't
it
it?
is without bottom rights and top left. I mean, just swap these 2 words. You see what I mean?
Yeah. There you go.
Thanks. And we need to take this as a set as well.
It is not a set. That should do it.
Okay.
And then we can just change one line. And we have no output, which is fine.
We didn't print anything.
I'm just thinking, so we're adding the state. If it's in... Yes, so this one, are we doing this in the right order? Sorry, I have to read this again. It's been so long since I've looked at it now. So we go through, if it's inbounds, if it's inside, we add it. Otherwise it's outside. If it's a path cell, then we change it from in to out. And I think this means we're also not going to... That's 15.
And what is our input?
Not sure. That doesn't seem right.
I don't think you want to add the path.
Is that already included? Yeah, so that's 4.
That's also wrong. Do you want to add the path minus 1 divided by 2?
What? Why?
Path minus 1 because you're counting the first cell twice, in the beginning and the end. Divided by
No.
2 because it makes the answer right.
Okay. What do you say, path?
No. Can I type what I'm saying to make it clear?
Yeah, sure.
So what I'm saying is that we want to add the length of the insiders, the length of the path, minus 1. Is path the variable that I'm interested in?
So path is
Path
the
as
full
set.
path.
How about path as set? Then that gets rid of duplications and I don't need to subtract 1. How about
Yeah.
that? And the insiders is also a set. So that's nice.
Oh, yeah. Yeah, but it's 4.
Well,
I'm
when
tempted
are we
to-
adding to the insiders? Oh, this is very confusing to me. Okay.
So we always start outside because we always add 1 to the bounds.
hmm
And then we add it to the outside. And then we add it to the inside, if we're inside. If
And
we
this,
hit a
can you
path-
explain this line to me because it's very confusing. How does it? The problem here is Python. I don't even understand what this line does in terms of Python syntax. Ah, okay. I think I see it now. Yeah, you may want to keep it the other way. I don't care. It's just that I needed help to understand it.
Oh, good. And then we just simply switch the cell state. Can I print what's going on?
Yeah.
Because I think it's right, and I'm just struggling to see what the issue is. So, first of all, I'm going to. Um, for yeah. Now this is going to be an issue, isn't it? Well, no, it's not. Yeah. Okay. And then if cell in path as set, then row plus equals x, else row plus equals dot. And then I think just print row. Does that look right as the thing that we're meant to be looking at?
That does look right.
Okay. So it goes 2 down, 2 right, 2 left. Yeah. Okay, cool. And then print the insiders.
Can we just do it in one function? Because it's either going to be an insider or a path or a this or a that. So could we just have a if cell as path x, or maybe even a hash, right? So it reads as the problem. And then if the cell is in the insiders, print I.
I kind of want to see if it overlaps or not with the
Okay.
Path or not. But anyway, it's done.
Yeah, run this last
So here
version.
we-
Okay, I see that now. The problem is that we are just...
We're not counting the insider.
We are not bailing out of being inside soon enough.
Our condition might be wrong.
I suppose we just put this line below.
Try it.
Run it.
It's not defined.
But that's the spirit. We need to work out the previews of this and store the previews of that and deal with nuns and off by one mistakes in the temporal axis. But the logic is right. We need to only add,
Yeah.
or not even that. I got the wrong line. What I mean is this line. In the temporal axis, this line is in the wrong place.
In the temporal.
Yeah. Let's run this version again, the version that works. Can you run that again, please?
Yeah, sure.
So as we are going, as we are tracing our ray from the bottom left to the top right, we are getting inside here.
I think we should be inspecting the current cell before we count it as inside or outside, and then change it going forward.
Can you
Like, I
say
think-
that again more slowly, please?
I think that like here we're adding it just purely looking on the previous state, but actually we should be adding it looking at the current cell. So like we should be doing this, I think maybe like this, and then like state can be none to begin with.
Okay, your solution
Kind
is
of.
headed in the direction that I was thinking. So what happens when you run it?
Looks a bit off. Oh, state is sorry. This it still should start as out, probably. Yeah, no, that's not quite right. Tempted to look at my code from the other day, but it's fine. We'll work this out.
We are changing the stage. And then we are adding stuff. Shouldn't this happen below?
Yeah. I feel like this should.
These lines should happen
to me.
above.
Yeah, I feel like the switching should happen below.
Yeah.
But we should also, like, do if state is in cell or like that, I want to say.
No.
I mean, that does work.
No. That does not work. That's not an interior cell.
Which one's not an interior cell?
You are adding the insiders so that you don't have to add the length of the path of the set. Okay. Run that again, and we should get our 9. And we do.
Yeah.
Okay. I thought that he wanted to exclude the path itself from the interior, from the insiders.
Should we try it with a bigger, more complicated input?
Yeah.
What's an example that they gave us? That's what they gave us. How does that look at from the output? If you look at the console.
The answer that we should be getting is 62. And we
Yeah,
do.
we got 62. Yeah, and it
Okay.
looks about right, doesn't it? Okay. So should we run it on the real deal?
Run it on the real deal.
Okay. We'll do that, and I'll comment out the test input. I'll run it first on yours. 2?
No,
What?
that's not right. That's not the right input.
I think it is. I think there's just a major issue with the code. Is there some? Is your input's not in there? You didn't paste your input. That's why. I'll run it on mine for a second and then paste yours in the meantime.
Okay.
Yeah, paste yours, and I'll check my answer in the meantime. Although all the printing is too much, so I don't actually know what the output is.
I pasted my inputs, okay? So if you're running this again, there is a chance that you're running with my inputs.
Yeah. Yeah, it should now be running with your inputs, and 36725 is your answer.
That's the right answer. Ah,
Hey!
congratulations,
That was-
David.
That was painfully easy, wasn't it?
And it's not even that complicated of a problem. Our brains are fried.
No, I think we overcomplicated it, but for fun. But that's fine.
Yeah. It happens
you
to the
up
best
for
of
reading
us.
part 2? Or are you too fired?
No, I want to know what part 2 is about. I need to know.
Yeah, definitely. I definitely want to know too. Cool.
We may not
actually,
do
can I
it
grab a
now, but
coffee?
we need to know.
Yeah, exactly. Can I grab a coffee before we read part 2?
Yes. And while you are doing that, I will be explaining to the people at home what I think I should do to the other implementation, the Green's theorem
Yeah.
implementation.
I would be very interested to learn more about that because it seems like an incredibly useful concept, but I don't feel like I'm capable of coming up with the Green's theorem on the fly, like proving it. So I'll leave
What-
that to you for now.
Okay. The whole clockwise and counterclockwise situation, I still stand by. The only thing that is missing in this implementation is, I think, the situation going here. It's going on here, where we are going up clockwise. So we are going up clockwise, and we are subtracting x, and this is now in the negatives. So what I want to do is if my x is negative, then subtract 1, else don't. And of course, I don't know how to write this in Python. And I kind of wish I knew, because if I knew, then I would be able to run this code. Let's real quick find what is the ternary operator in Python. Oh, it is that thing that David wrote. And it's something that came up like 3 times already in Advent of Code, and I still don't grasp it. But I think it reads like this.
I'm back.
Hello.
Oh,
And
you're starting to love those Python ternaries, be honest.
yeah, I am. I think I am understanding them now but they still take me like a solid second. I guess what I need to do is first move this to the left and then put question mark and column, and then it makes sense.
Yeah.
But Python
Or
tries
just
to
try-
be like English. Would you ever say this
Yeah.
in English? You wouldn't, right? You would say if
you would.
x
You'd be
is
like-
less than 0, then -1, else 0. You wouldn't say something if else blah. You wouldn't put the condition
you
in the
would be
middle.
no, you'd say, I'll eat if I'm hungry, else I'm fine. Right?
Ah,
I mean,
I don't know. I don't know.
like the baby will eat if she's hungry. Otherwise, leave her, or else leave her. You know, like you would. That is kind of English, honestly.
I guess I have been programming for too long because I would
Yeah.
probably say like, if the baby's hungry, let's feed her. Otherwise, let her play. And similarly, when I'm going down, I'm clockwise and I'm going down. Then I want to do this if situation that we learned about. So if x less than 0, else 0. Now, is this less than or equal? I want to say less than, just like that. And then for the counterclockwise, same argument. Now, there will be all sorts of off by ones and greater than or equals and less than or equals and all of that. So I don't think it's even worth running this code because it will probably be wrong because of off by ones. But I think that the logic is there.
Yeah. Cool.
Okay. So let's go to part 2.
Let's do that. Okay. The elves were right to be concerned. The planned lagoon would be much too small. After a few minutes, someone realizes what happened. Someone swapped the color and instruction parameters when producing the dig plan. They don't have time to fix the bug. One of them asks if you can extract the correct instructions from the hexadecimal codes. Each hexadecimal code is 6 hexadecimal digits long. The first 5 hexadecimal digits encode the distance in meters as a 5-digit hexadecimal number. The last hexadecimal digit encodes the direction to dig. 0 means R, 1 means D. Okay. So the instruction in the above examples, the hexadecimal codes can be converted into the true instructions. So that is equal to that. So there's like an extra instruction on every line?
No,
Or the first ones are to be discarded?
Just, forget about the first part. Now we are only looking at the thing in parentheses.
Okay, cool. And... Okay, so the first character. So how does the conversion work? Let's just read the description.
So we are looking at
6. The first 5 digits encode the distance in meters. So that's the distance. And then the last one is either 0 or 1.
0, 1,
Or
2,
no.
or 3.
Okay, cool. Okay, cool. That makes sense.
Now, naturally, this is not only a parsing problem, because now it will be huge, and trying to do this by instantiating the board will not be fine. It will not give us a happy ending. Even the perimeter of this is kind of huge. So Green's theorem is the way to go, right? Because in that case, we don't instantiate anything.
Okay. Well, I think as a first step, it makes sense to fill it out, though, right? Like finish this bit off. Like, just do the parsing and then try and run the algorithm and see if it works.
Yeah.
And then if that doesn't work, go back to Green's theorem and finish that off. Did you
Yeah.
manage to verify, by the way, whether... did you run it?
I
Did
can't.
you Oh, okay. You can always request. I'm just going to kill the terminals and then make them read write. Why can't I? Okay. Go to live share, then make read write. Make read write, make read write. Okay, and then I can come in here. 2023 and 17, and then I could have just run the above code. So it's 4 for main green stream as the output at the moment, although I'm not sure if you're printing the right thing.
I cannot even see the terminal yet. Live share with terminals just plain doesn't work. But what are you doing? Are you dealing with main.py or the other file? And are you running it? Are you looking at it? Where are we?
Well, I was just running Green's theorem. Oh, you got the right answer for Green's theorem, I think. It's 6. Is 6 correct for the current input?
I think it should have been 9.
Yeah. Okay, well then it's wrong. I just wanted to verify whether it was coming out right or not to just be teased. But let's go back to main.py, do the parsing correctly, and then we can do the rest in a second.
Yes, and create a copy of main.py.
Yes, okay. I'm so inconsistent with my naming. Like, your repo is perfect. It's all like part --1, part --2, and all of mine is like totally underscore David copy 3 or whatever.
And we are working on day 18 under the 17 directory.
Well, that's easy enough. Okay.
Well, it's easy because you are not on the other end of the live share.
So main.py.
Okay.
I mean, this is simple enough to change now. First of all, we don't need this. And second of all, we don't need that. Now we can... I don't know if you can have multiple underscores like that, but that's fine. Then distance. So it's up to the first 5 characters.
Well, in this line, I suppose you could put a number 2 here because we don't want to simply ignore the parentheses. We also want to ignore the hash sign.
Thank you. And then, is it direct? Not direct. Yeah, direction. And I'm going to have to look up how to parse. I'm going to say this is distance as hex string. And then distance. Yeah, okay, I believe that. Is it going to be 16?
Mm-hmm.
Isn't it 8?
No, it's hexadecimal.
No, it's 16. Yeah, okay.
And the direction we also need to convert from number to direction.
Yeah. Well, oh yeah, sorry.
0 is right,
I prefer to do this like this. Direction string to direction. 0 is
Right. Coming
Is-
back to our conversation about the ternary operator in Python, what does it look like when you have to start chaining ternary operators? Because that's kind of
It
what
looks-
I would do here.
Yeah, I'm sure it's possible, but it messes with my head.
Mm-hmm.
We can see that in a sec, though. So this is 0 is up. Could you just tell me the config?
0 is right.
Okay.
1 is down. 2
1 is
is
down.
left. And 3 is up.
Um, there you go.
It doesn't read too terribly because at least the conditions are next to the consequences.
Yeah. So this is saying like, you basically have to evaluate it from right to left. So you're saying if it's 2, then this. Otherwise up.
No, it's evaluating from
No.
left to right, but it is doing the
From the
trick
middle.
that I mentioned. It's taking this, evaluating it, if true, that, otherwise, she blinks. And then it's
Yeah.
repeating and doing this.
Yeah. Yeah, that makes sense. Cool.
Cool.
Um,
Run that for a small board because I think
Yeah.
that's going to work.
yeah, so it's throwing with color 6.
It should be 5.
Oh, sorry. Yeah, I mean, we have some stuff printing out. Let's do... Where's the example board? Let's get rid of all of this.
You probably want to remove the XH0.
I just want to, like, read the... I don't want to remove it just yet. I just want to verify that they're correct. Get rid of that. No. Okay, so is it right 419637? Is that correct? And then, like, looking at the...
9.6, you say. What is something that ends in 9.6 in the console? What are we looking at?
No, just I'm looking at the first instruction. Is direction right? And then the distance is 461937. Is that correct?
461937 is correct.
And then 560 is... Yeah, okay. Then
Yeah.
I believe it. Cool.
Yeah.
Okay, so we've got that. Do we need to change anything else?
No.
I guess not. Okay. So let's run it for a big input then. I mean, well, may as well run it for this one. Wow. It's not completing.
How surprising. The answer is in the order of almost 1 trillion.
We actually don't need to... We don't care about the outsiders, so we don't need to do that.
We don't care about the insiders either. We could just +1.
That's true. I mean, that might... Is there an even, like, smarter way of doing this?
Well, and that's the least of our problems because we're still instantiating the path. We're still coming up with a set of everything that is in the path.
Should we see if that part even exits?
Yeah.
Excuse me.
And this is dealing with the small input.
Yeah. I guess there is probably a trick that if you know. Oh yeah, no, it did do that. Oh no, sorry, wait. Yeah, that's the path. But like with a very small input. It's not a directory. What? Okay. Yeah, so yeah, that's the length of the.
So at least we can
Yeah.
trace that path.
Yeah. For this tiny input that we have, yeah. Okay. I'm just thinking like it feels like just changing this distance. Can't we just like view it as just like zooming in and zooming out of like a a small grid versus a big grid and just making that area like if we found like the ratio that we need to increase the insiders by and we could just divide all the distances by that ratio, then we could just multiply out the
Ooh, that is smart. Because we are not adding more instructions, so we are not making the board more intricate. If we were making the board more intricate, you wouldn't be able to zoom out. But we are not making the board more intricate. We are just kind of exploding it, making it a lot larger.
Mm-hmm.
We don't have more instructions. So I guess we could find the greatest common denominator of all the lengths or all the, how do we call these things? The step length, the direction length. Do we call this distance in meters?
Instruction distance.
Yeah, we could find the greatest common divider of all the distances, and then divide, and then in the end multiply by it again.
Yeah, that's what I'm thinking generally. I'm not totally sure how it's going to work for area and distance. Like, is it just simply divide and multiply? But if it is, then that's great. Like, I'm just thinking, like, does it get complicated when it becomes like squared?
Right,
as an
because
area?
if you zoom out 2x, the area becomes 4x. And if you zoom out 3x, the area becomes 9x. So you just want to square the greatest common denominator before multiplying it back up.
Yeah, that sounds about right.
That sounds cool.
Right.
And maybe they thought about this trick, and the distances have a greatest common denominator that is huge to help us out.
Okay. Let's try that.
I love this idea.
It's a funny one. Well, you don't need to do this yet. We could do it earlier than this.
We could do this earlier because we are trying to prevent the work that is going to happen on this other block. Yes.
Unfortunately, it's 1. Wait, does it need to be a common denominator? Like, can't we just like? It could just be like a floating point. I guess then it won't be super accurate. We could run into floating point issues.
You could divide by the smallest.
Yeah.
good call. You're on fire here, David. Just don't tell me that they have an instruction with like a very small step. No, they don't. Ooh, but they have something. They have something that bugs me. In the real inputs, maybe not in the example inputs. Okay, so I want to test something in Python real quick before we proceed, just so I don't forget about this. They have 6 lines in the real inputs that start with 0h. In some programming languages, for example, in JavaScript, if I start a number with 0h, then it is in octal, I want to say.
Oh.
Maybe not in JavaScript, but there are some languages, I think C is like
But
that.
you can do like pass in or something with JavaScript, and if you do like the wrong parameter, then you can get it to screw up.
But I just want to test that in Python, this is not gonna mess us up.
Yeah, good point. Do you want to do that in my terminal?
I don't know how to do that. How would I do that? Oh, I cannot even type on your terminal. So can you please verify that?
Sure.
Thanks.
So, and then
Okay. And can you
that
do
okay?
this bigger number, 08B5D0?
well, it's just B5D, isn't it?
No. A 0 to the right is significant. No, you are right. 0 is the direction. Yeah, you are right.
Invalid literal for int with base 10.
Well, that's
Oh, that
because
makes
in base
sense,
10 there is no B or D.
Yeah. I don't know, is that correct? Do you want to do it in JavaScript to verify?
No. Wait a second. Can we do like 081 or maybe 08A? 08A. Let's do 08A. And that's a large number, so that worked out correctly. Yeah. Okay, it was a non-issue. And
Okay.
we can just, let's divide all the instructions by... No. We cannot do floating points. We have a discrete grid.
Mm-hmm.
We cannot do
Yeah.
floating points. We need to use the GCD, which happens to be 1. So that's no good.
Is that true for the real inputs, though? I'll just run it for mine. It doesn't... Yeah, it's also 1. Oh, they're all prime. Of course they are.
Yeah, they could have just thrown 1 prime in there, and that screws everything up.
Mm.
But that was a fun idea. It's too bad that it doesn't work.
But is it? Do we have to throw it away?
How can we salvage this? I don't think of any way because the grid is a grid of integers. Unless we made this a grid of floating points and then calculated the areas in floating point. But then even the idea of tracing the diagonal line doesn't really work in my head, because then we will need to do fractional blocks. No.
Yeah, I'm just wondering if we could do a. We could. Okay, I had a kind of crazy idea. No. I was just wondering if we could like
One can hope.
like shift everything a little bit so that we find an integer which works, or like round everything in a specific way so that we can find this. But it's not looking likely, is it?
So
I'm just trying to rack my brains
Okay.
if there is a way of making it work, but I think I have to abandon it. I think we've proven that by finding the GCD being, unless I've calculated the GCD incorrectly.
do you want to call your GCD function with fake instructions that we know the GCD for?
Yeah. I mean, no, this does look right. This does look right, doesn't it? But yeah, I mean, may as well. But I think we're going to have to just think of a different strategy.
Why are you writing this in Python? Just create an input. Create an input. It's easier.
I don't know what you mean.
I meant like go to line 1472 and start changing the input instead of having to write it in
Okay.
Python syntax.
Okay, it works. So,
Mhm.
yeah. Okay, I think we have to move on from this idea, unfortunately. And be a bit smarter.
Yeah. Well, about that, I really
Yeah.
think that the way forward is to come back to the Green's theorem implementation and try to work out the edge cases and make that work.
Yeah, because it would be a very efficient program, wouldn't it?
Yeah. We would just traverse the path and we would be done. So it would be like order of n.
Okay. We've been on the phone. It's streaming for almost 3 hours.
Yeah.
We've got. Should we do another 8 minutes on the Green's theorem? See where we get to, and
Yes.
then have some lunch.
Yes. So
Okay, sounds good.
yeah, let's switch back to this. And I suppose that if we work out this plus ones and minus ones, we will figure it out. Do you want to try and do that?
Would you mind briefly explaining to me what this is about?
Okay, yeah. So the best way for me to explain is to come back to XCollyDraw, which I have lost.
Oh no.
No, this is not the right one either.
I'll just type the link though.
Yeah, I will copy the link again. Paste it here. No, that's the wrong link. Okay, I'm back in XCollyDraw, but it is not the correct one because I don't see your
Yeah, it is.
cursor.
Oh, I'm not like in it right now. I mean, I'm here. I'm around.
Uh-huh, I see you. So, what is the best drawing for this? I think this may be the best drawing for this. So let's work out this clockwise example, and then there is another clockwise example. This clockwise example, as I'm going down, I want to add, can we perhaps keep this side by side, because that would be fantastic. So I am going down clockwise. I want to add x plus 1 because I want to add 3 columns. So that is x plus 1 times instruction distance plus 1. That seems right. Now, am I doing the plus 1? What does this condition say? If x is greater than 0, let's say greater than 0. Okay, so far I'm just doing x plus 1. Maybe we don't even write the if for the time being, just to make things simpler step by step. How does that look? That looks
Sure.
right. Okay, then when I'm going up in a clockwise motion, I want to subtract x times the instruction distance. And this should get us the right answer for this input. Now, let's do before we proceed, let's do the slightly more contrived example in which we do one turn. We don't have a drawing for this yet. Or we had, but then we lost it and I am recreating it. On this one, we are going up on a cell that has a label of 1, 2. So in this case, we are going up. We want to subtract x times the instruction sequence. Yeah, that seems right, because that will get us 1, which is x, times 1, which is the distance. Perfect. Now, let's consider this other case, in which I am still doing a clockwise motion, but this time I'm going into the negatives, which will mess our heads up. So again, I'm now going up, but I want to add some stuff. So let's see how that could work out. I'm still going clockwise, I'm going up, and I want to add. Well, here I have a subtract, but that's all right because I'm going to use x, which is negative. Subtracting something negative amounts to adding, so that's all right. How much do we want to add? Well, we want to add 3 columns, and our x is minus 2, so what we want is to do minus 1 in parentheses, just like that. But hey, that's not all, because now we broke the previous example. So let's add a conditional. To add a conditional, I put it in.
I think I found it.
You found what?
Well, I think I found at least one thing which could work is that we might be calculating a negative area. And I've just added absolutes to this max condition right at the bottom. see this line here? If we just take the absolute here, so if we're going in a negative space and we create a negative area, we could just do the absolute of those two, and then that could. I mean, it outputs 9 now, which is nice.
Okay. And what is the input that we are dealing with? We are dealing with an input that goes to the left, then up, then right, then down. Well, my clockwise thing is already doing the right thing now for this input. I suppose. You don't even need the absolute or the maximum. Just print area clockwise and you see that that's 9.
Okay. Yeah.
It is.
Clockwise is 9. But I'm wondering if this would maybe just simplify. If you might not need to do all this minus and plus if you just were able to do the absolute. Well, they probably you do need to think about all of this because.
Well, let's
You
take
are
out
going-
the junk. Okay, I'm going to expand this. So by your argument, we could compute clockwise and counterclockwise, and we could take the absolute values and max. So by your argument, I should be able to remove the junk from here and get a counterclockwise example correctly. Or at least I should have equivalent junks. So when I'm adding, can you reformat this? Because all these new lines, they're like, ugh.
Yeah, they are really annoying.
Oh, I thought that you had okay, your automatic formatter is doing that. So all right, let's just leave it.
Yeah.
So the area clockwise plus, which we have seen here, has a +1. So the area counterclockwise here should have a +1. So it's +1 and +1. That's all right. The area counterclockwise here should match the area clockwise there. So it is if essentially just this.
Mm-hmm.
What does that give us?
It gives us area clockwise is 9 and counterclockwise is -3.
That's okay. And we are still dealing with a clockwise example. So now let's deal with a counterclockwise example, see what happens. So a counterclockwise example would be, for instance,
Should we do
this.
counterclockwise top left?
Yeah. So this would be go to the right, go up, go left, and go down, just like that. And what is the result now?
Area clockwise is -1, counterclockwise is 9.
Okay. So far the idea seems to be holding up.
Nice.
And can we run now the test input, and we should see the number 62.
70.
Oh, shucks. Now,
Would you mind? Mm-hmm.
I was thinking that maybe we should deal with this edge case here of the corner in all 4 directions and in all clockwise and counterclockwise situations, because there are still some +1s and -1s that we need to add, I think.
Mm-hmm.
And also this less thans could be less than or equals. Hard to tell. And all of this could even be wrong. My whole theory could be wrong of how this thing works.
So
Do you want to continue tomorrow?
Yeah, let's continue tomorrow. But I would love to understand this and get to the bottom of this. Although I am just very tempted to like just find somebody else's solution to this, and read that, and then try and re-implement it after reading their solution.
You mean you want to cheat and look at the subreddit for the advent of code?
No. I mean just the general way of computing the Green's theorem. Like,
Okay.
Just see some other like implementations and read through those, and and then maybe get there. But yeah, anyway, that was great fun, and yeah, we'll continue tomorrow.
Yeah, we are powering through here. It is, wow. It's a simple problem,
Yeah, well,
but for some
numbers
reason it was a
make it
lot
hard.
of work for us. Just like yesterday.
well, yeah, but the numbers make it tricky.
No, the big numbers, the part 2 makes it tricky. Part 1 wasn't tricky at all.
No, part 1 wasn't that tricky, but we did, like, I don't know. If we hadn't done day 10 before, I would have found it really tricky,
Yeah.
I think. Anyway, but yeah,
Yeah.
it's been fun.
Good job so far. I'm happy that this is your day.
Yeah.
All right. I want to say thank you to Bo and to Saurav and Feminine Melon University, Not Was One. Thanks for being here on the chat with us. And tomorrow, when are we meeting?
I am free tomorrow, so I have nothing planned. So up to you.
Okay. So let me see if I have something planned. I could do it in the morning at 10.
All right. I'll see you tomorrow at 10.
All right. Ugh. Enjoy, everyone. See you tomorrow.
Have
Bye.
a lovely rest of your day. Bye-bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.